Okay, so normal stress. So imagine that were to have a rectangular beam, just like this one, and we were to start pulling it apart, just like this, with a force of 20,000 newtons, or 20 kilonewtons. So, as we pull it apart, it undergoes a stress, and the reason why we call it a normal stress is because this force is perpendicular to its cross-sectional area, or it's normal to its cross-sectional area. So say this beam were to have a cross-sectional area, so if it were to have a height of 10 mil and a depth of 100 mil. So the way that we calculate normal stress is just by just like the regular stress formula. So stress given by sigma is equal to force over area. So in this case, our stress will go into pascals, or units of pressure. Our force will come from these newtons here, so 20,000. Our area is our cross-sectional area, which we can calculate as we do the equation. So we'll do that now. So our force, 20,000 over our area. So I'll convert these to meters as I go, because 1 Pascal is equal to a Newton over a meter squared. So 10 mil is equal, 10 mil is equal to 0.01 meters. 100 mil, 0.1 meters. So this ultimately goes down to 20 million pascals, or 20 megapascals. Okay, so if we pull this beam apart with this cross-sectional area with 20,000 newtons, it will experience a normal stress of 20 megapascals, and that makes it stretch. But if we were to push on it with the same amount of force, we would have the same amount of normal stress. It would just be in compression instead of tension. So the way we do that is if we were to compress it, these arrows, because they're just in opposite direction, we can just put a negative next to the force. So we just go through the same process, but we just add a negative wherever we see 20,000. So ultimately these will become negative. So if we were to start pushing it or compressing it, it would then have a normal stress of negative 20 megapascals, whereas with the tension, pulling it apart at the same force, we would have a positive normal stress. Okay, so thanks for watching.